brave souls who made it to school on a wonderful day. Good to see you, good to see you, good to see you, ladies and gentlemen. All righty. Open up your computers, get to slide number 22 in your EISN, and that is what you are going to be doing. Hang on a minute. All right. Welcome, 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 welcome. Good, 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 good. All righty, all righty. Farhan, good. Jennifer, Lizeth. No Lizeth. Mitzi, Jasmine, no Jasmine. Angel, no Angel. Olivia, Ephra, good. Kiana, Cynthia, Ava, Aiden, no Aiden. Rose, good. No Isaiah. Austin, good. Let's see, good, 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 good. All righty. All right, ladies and gentlemen. So here is what we got going today. Today we're going to start talking about Boyle's Law. But before we do that, ladies and gentlemen, you are going to take a few minutes to do some pressure conversion. So get to this slide right here, ladies and gentlemen, and follow me to the back. Let's go, let's go, let's go, let's go, let's go. Bring your computers with you. Bring your calculator with you. You got enough crap? No. My goodness, child. So, come here. Hurry up, hurry up, hurry up, hurry up, hurry up. You're not hurrying. Let's go, let's go, let's go.
Oh, does he have?
I would, but 3/4 of the people aren't here. You're only 1/4 of a person as short as you are. You're just the right height. Your feet reach the ground.
Oh, Mr. Michelson. Yeah, Michelson. I feel like he's against everyone.
Okay, so here's what you're going to do, ladies and gentlemen. At the top of this page are the conversions that you need to get from any unit of pressure to any other unit of pressure. So you are going to start by taking 815 millimeters of mercury and you are going to convert it into PSI. To do that, the unit that you are going to needs to go on the top. So for PSI, the standard pressure is 14.7 PSI. The unit that you are in goes on the bottom, which is 760 mmHg. Cancel, cancel, left with PSI, do the math. Now the math is going to involve you taking this number times the one on the top and then dividing it by the one on the bottom. That will get you your answer in PSI. Now you have a choice to go to ATM. You could take this number that you got in PSI and you could convert it, or you could go back to the 815 mmHg and you can convert it into ATM using the same number on the bottom and using 1.0 ATM on top. Now, obviously, when you're using ATMs, that's a 1. Do we need to multiply by a 1? Do we need to divide by it when it's on the bottom? But that's the only one in here where you have a 1 in it. Otherwise, you are going to have two numbers here. You will have to multiply by the one on the top and then divide by the one on the bottom. This will give you some answer in ATM. Then, ladies and gentlemen, again, you can go back to the original number, or you could take the one you got here and convert it. But if you go back to the original number, it sets up the same way. The only thing that changes is the number on the top each time. Okay, 15 minutes, go to work.
Like back here?
Yeah. You might as well, it's easy. There's nowhere on your thing to do it. Of what? I'm not erasing it. Come back with as much as you need. Then go get your beer and get one copy down. Let's not be lazy. You don't need a phone to do your work. Come on. Well, you're using the tables to use as a workspace to do these conversions.
Really? I didn't know that.
I was explaining it to Cynthia. She's a little bit slow. Leave her be.
No, she's not. Don't talk about
Okay? Short people, things go over their head a lot easier.
You're not that tall, Mr. Brand.
No, I'm just the right height. My feet reach the ground.
Everyone's gonna use that.
Then we're all just the right height.
Look at my good pants. Mr. Brand, did you eat my good pen?
Did I eat your good pen? It was tasty. It was tasty. I will admit that. Molar conversion. Okay? You're using this over something else when you mix it up. Now, you can go back to this number. You click on the bottom and the number that you give. Take that. You don't have to get every single one on the page done. If you can do it once, you know, 2 sets of them and you got it, great. It's just a matter of how much practice you need. Some of you may need more. Some may need less. But this is what your quiz is on Friday. Again, doing is better than watching. If you're just watching, you're probably not getting it. So make sure you try a couple. Yeah, you're using what we did last week, where we had some grams to mold, and mold. And that's important because bigger underneath and that's maybe. Are you?
No! Don't use my eraser or my sponges. Put it back over there and then get the wash.
When you sit down, ladies and gentlemen, you need to sit with someone who you are going to work with the activity on. So you need to sit with someone who you are going to work with the activity on. Ooh, that's bad. Perfect team. Okay. Again, you may want to look in the definition of perfect in the dictionary. Two wrongs don't make a right, but three rights make a left. Okay. Yep. Three. Okay, what you're looking at, ladies and gentlemen, up here is the answers to your conversions. By the way, gotta be this number right here with the 0 at the end. Gotta be the decimal right here, otherwise you're not in the correct number of sig figs. All of these problems were in 3 sig figs, ladies and gentlemen. The numbers that you are seeing me put up there are all in 3 sig figs, so that's what you would have to do on your quiz on Friday to get full credit for the problems. Questions?
Do you not want us to round?
That is rounded. Why? Which one are we talking about?
Multiple. I'm just the ones I've like rounded. I'm just like 1/10 up.
Okay, I thought that when I did these in my calculator that these should have been already rounded for you. I would have to check. Is there one in specific that you're looking at?
Wouldn't the KPA be 4 sig figs?
No. Good question, but it's based on the sig figs that were in the original number.
Oh.
This is the original number, this is the original number, this is the original number, and this is the original number. The KPAs is a conversion factor. So, for example, 100 or 1,000 milliliters in 1 liter. We don't let conversion factors limit our sig figs. And in this case, these up here are infinitely significant. Even this 760, that's not just 2 sig figs. Because it is an exact amount, it is infinitely significant, and we don't let it limit our sig figs. Okay? So we look at the number that we started converting. However many sig figs were in it, that's how many should be in our answer. Okay? Was there one that you think I had messed up?
The PSI to the KPA, the 437. When you do it on the calculator, it's 43.75.
Okay, here is one thing that I will tell you. Depending on how you do it, let me explain what I mean. If you went back to the original number and you did your conversion, or if you possibly took this number and did your conversion, we might end up slightly different in the last place. That is a good point, okay? So depending on if you did rounding in your calculator, or if I might have left the whole number in there and just went to the next conversion, we could be slightly off, and that would be okay. That would be okay, all right? But again, we should be talking maybe 1/10 or so.
Yeah.
We shouldn't be talking about much more than that.
No, they're all just like 1/10.
And again, maybe it was the way that I did my calculation compared to what you used for yours. Again, we're okay with that. Questions? Okay, so here's what I need you to do, ladies and gentlemen. Of the 2 people who are together, slide over, Jennifer. Okay? You and Mitzi need to be sitting together for this. Or slide your desk over or whatever. That's fine. Okay, of the 2 people who are in your group, one of you needs to go to that circle in the bottom left-hand corner of your screen and click on it and open up all of the apps that are on your Chromebook. And the app that you are looking for, ladies and gentlemen, is one that looks like this here. One that has a red wavy line and underneath it a blue dotted line, and it says Vernier, or it may just say graphical analysis. One of you needs to click on that and open that up, okay? And the reason I ask one of you to do it right away is because sometimes it takes a while if you've never opened this program on your computer. Then, ladies and gentlemen, we need you to come up here and grab 3 things. Come up and grab a syringe, come up and grab a pressure sensor, and come up and grab a GoLink. Okay? You need one of these for the group. So come on up and grab these, ladies and gentlemen.
Just one of each?
You need one of each for your station, for you and your partner. Just grab one. Oh my gosh, I didn't know you were going to be the slowdown for the group.
Is that where you're at?
Okay. Now, one or both of you, the choice is up to you. Probably better for your other partner who didn't bring up the graphical analysis. Go into Google Classroom. And for you, ladies and gentlemen, you need to go into Google Classroom and you need to open up this Boyle's Law activity. Okay? If you both want to do it, you are welcome to. I'm not collecting this, but we're going to use this to show you what we're going to deal with right now about Boyle's Law. Okay? So one should have the probe set up, one should have this. Okay? Again, if you both want this, that is absolutely fine. Rid of this. Okay. So, what this is, ladies and gentlemen, is this is a pressure sensor. We are going to start looking at our first gas law. And our first gas law is Boyle's Law. Now, Boyle's Law relates two of the four variables that we are talking about. The four variables are pressure, volume, temperature, and amount of gas. Well, the sensor is for
Pressure.
good. The syringe will allow us to control what about a gas? Nope. You got two more choices.
I know, I'm thinking.
The volume. The volume. Now, you're right. Like this, Kayana, this would control the amount of gas in there because you would be pushing it in and out. You'd be changing the amount in there. But we are going to hook this up to the pressure sensor and make this a closed system. Don't do it yet. Just wait. Okay? And when you do that, now gas cannot get in or out. So now we're not changing the amount of gas. Now we're changing the pressure. Okay. First thing, ladies and gentlemen, this little Gold League thing has a USB in it. Plug it into your computer. The computer that has the graphical analysis up. Yes, thank you. And then the other end of it, you plug into the pressure sensor. There's only one way to plug it into there. So plug it into there, ladies and gentlemen. Now, hopefully, ladies and gentlemen,
It opened up a table.
that's fine. We'll get to that. It should look like this, correct? Okay, good. All right.
Just the front one.
I don't want you to fall asleep. I got them turned down as far as they can go. Okay? All right. So, okay. So, down in this corner, right down here, click on where it says mode. And then choose event-based instead of time. Okay? Event-based instead of time. Now, if we technically want to make this even better, ladies and gentlemen, we should name the event. And the event that we are going to name is going to be volume. And underneath, measured in milliliters. Is there anyone who didn't see how I got into this part here? So this little box down here in the corner brings up this screen, data collection settings. Please set this for event-based, event name, volume, units, milliliters, and then hit done. And now it has a graph for you, but it also has a table for you. Now, the reason I asked you not to connect this to the pressure sensor is we need to set this first. So when you look at this, you can see 2 or 3 lines on here, ladies and gentlemen. Now, it really doesn't matter which line you pick, but you need to be consistent. So there is the line that is at the very, when I'm holding it like this, at the very top, right where the cone starts to narrow, that cone shape.
Yeah.
And then I see 2 other lines where it's up against the side of the container. I don't care which one you pick, but pick one and put it at 60 milliliters. So 60 milliliters is way down at the bottom. So set this so that one of those 3 lines is at 60 milliliters. And whichever line you are using, you are going to use every time to measure the volume. Does that make sense?
Yes.
So I don't care if it's the top line, the middle line, or the bottom line. Okay? Put one of them so that it's right on the 60 milliliters. Whichever line you are using is the line you are going to use throughout the activity. Are we clear? Okay, so now you can take, and this will screw into the pressure sensor, ladies and gentlemen. So you bring it on, and then literally screw it in a little bit. Be careful, these break easily on the pressure sensor. So all I did is put it on there and screw it in, okay? Now, an important thing in this lab. We are going to adjust the volume and we are going to read the pressure when we adjust the volume. That's what Boyle's law is about. He studied the effects of volume and pressure on each other. Now, when you do this, when you are going to be adjusting the volume in your syringe, do not hold the pressure sensor. Hold the top part of the syringe and your other hand on the bottom part to move it in and out. If you hold up here and you push on this, you will break it right here, and then the sensor is useless.
How did they break so easily?
Because they're plastic and that's the way they made them. And the worst part is I could take it apart and I could see what needs to be fixed, and they won't sell me the part to fix it. So we avoid that by holding just the syringe. Okay? Just the syringe. All right? Now, what you are going to do between you and your partner, ladies and gentlemen, and you may need your partner's help in this, you may not. When you hit the collect button, okay, it's going to start reading pressures for you. If you want to see what the pressure is, you can go up here to this box up here, ladies and gentlemen, this square with the 3 boxes. And you can bring up a meter and it'll show you what the pressure reading is right now inside your pressure sensor. Okay? It'll show you what that is. Okay? Now here's the way that it is going to work. In your lab, always cool to go running down the hall of school. You are going to go to these different volumes and you are going to collect the pressures. Okay? So in a minute when we start, I'm going to ask you to someone hold the syringe and get it down to 55 milliliters. And then we are going to collect the pressure at that volume. That'll be what we're doing with one person. To do that, ladies and gentlemen, here's how it works. I'm going to hit collect. Now, it didn't actually collect anything yet. It just put us into the mode to collect. This is what is called event-based. What that means, ladies and gentlemen, is I am going to get this so that it is reading 55. And you'll notice my pressure changed up here as I did. Once I get it to where it is at 55, where I want it, then one of you, you or your partner, has to hit the keep button. And now it's asking you, okay, what was the volume that you had the syringe at? And you could type in 55. And it will now plot that point and put it in the table for you. Okay? And you can let go of the pressure sensor. You don't have to keep holding it at 55. Now, I'm going to get it down to 50. And when I get it down to 50, and I have it set there, again, a little bit difficult doing this with one person, but maybe you can do it. I'm going to hit keep. And it will again ask me, what was my volume? 50. And it will put the 2 points in there. Now you go down to 45. Then you go down to 40. Then you go down to 35. Okay? So, that is what you need to get done right now. And then, ladies and gentlemen, when you're done with this, the other person can put it into the Google Sheet in the table that I have set up, because then we're going to take a look at it as we do. Questions?
Should it be that high? Like when
What?
you had it at 60, it was like over 100.
Okay.
Should it be like that? Because ours isn't.
It'll all be different depending on when you put it in, what it was like. They should, again, not every one of these is exactly the same. Maybe yours is different, but it's okay because, again, we're not using the 60. We're going to put it under pressure at 55, then at 50, then at 45. So just go through and collect your data. Now, obviously, what do you see is happening to my pressure here?
Going up.
Going up. So if you do one and it doesn't go up, then we probably have a problem. Okay? But go through and collect all your points, all the way down to, I think it says 20 in the Google Sheet for a volume. Get it collected right now between you and your partner. If you want to hold this on your desk like this and push down, but push down again on the syringe part until you get to where you want to. I don't care how you do it, but you need to get the volumes where you want them. And I think after a while, it may realize you're going down by 5. And when you hit keep, it may put up the volume for you automatically. I don't know if it does or doesn't anymore. Okay, let's get it done.
Is the last one supposed to be the same as the second to last?
Well, we'll talk about that in a minute.
And do I have to write this down on the table of the last one?
Well, you don't have to, but your partner should. One of the two of you should. By the way, when you do that last point, if your first point vanished, all you have to do is go back up to it.
Oh my god, it's exactly the same.
What's the matter? You're at sea. Now, some of you just experienced what happens as you go down in volume. Oops, I missed something here. Hang on. 130, 166, 191.
I think it's supposed to be.
Oh,
You did it wrong.
I missed 45.
Can you move like?
Yeah, here you go. Hit the key button. Right. No. What is it? So that is 221.95.
We're done.
Okay. Okay. Does everyone have their numbers collected?
Yeah.
Okay, now first of all, those of you who were doing the adjusting the volume, tell me what you noticed.
It was hard.
What was? What do you mean it was hard?
It was a lot of pressure.
Okay. What? Okay. So we know that literally the more you were pushing in, the harder it became, correct? Okay, tell me what kind of relationship this is. Why?
Because it's not constant.
Whoa! Constant and inverse are two different kinds of relationships. Let's not compare those.
No, isn't it direct?
Okay.
As one goes
Excuse
up,
me.
the other goes up too.
That's right.
But that's not how ours looks. We don't have
He's not here today.
It goes one up.
Not a problem. Not a problem.
Yeah,
Yep,
ours is
bye.
increasing, those are all increasing.
Okay. So, what kind of relationship again?
Direct.
No, not direct.
Inverse?
Well, look at what's happening to this number here.
It's going down.
What's happening to this number here?
Yeah, okay.
Okay. Now what you've just done is actually felt an inverse relationship. As the volume got smaller, you were literally pushing harder. You were putting in a larger force to create more pressure. Okay? Now what wasn't changing was the area inside there that it was beating on. Okay? So, again, inverse relationship. One variable going down, the other one going up. Okay? Now, some of you said the same thing. What do you notice about your last couple points? They're the same. Okay? Or about the same. Mine was 125.17 or 225.17. Why? Well, the volume went down the same amount each time. The volume went down the same amount each time. Let me ask you this. Those of you who were pushing on it, was it harder to get to 25 or harder to get to 20? 20. So what should pressure have done?
Gone up.
Should have gone up. Why didn't it?
Because there was no other.
Because the pressure, there's a lot of pressure there already.
I understand that, but it still was harder to go down to 20 than it was to go to 25. Why didn't the pressure go up?
Because it couldn't.
Why?
Because I said so.
Because you said so. No, there's an actual reason for it. What is the actual reason for it?
It reached its limit.
What did?
The pressure.
No, you just told me it was harder to get to 20 than 25.
Okay, well, obviously it wasn't because it's the same pressure, so.
So you're telling me what you felt was wrong?
Yep.
So wait, you're asking why was it hard?
I'm asking you, those who actually did it. It got harder each time you went down to a smaller volume, correct? Do you feel it was harder to get to 20 or 25? 20. The only reason it gets harder is because pressure is doing what? Going up. Why doesn't it show up on the sensor?
Maybe because it's maxed out.
Thank you. Not maybe, exactly right. Exactly right. You have maxed out the sensor, not the pressure. The sensor can't go any higher than about 225.
So your sensors suck.
Okay. Why do they suck?
Because they couldn't even properly read it.
They did, except every instrument has a limit. The balances will only go to 420 grams. That's it. You go over that, they won't read it. Sensors have limits. Now, here's the question. We know this last point isn't any good, right?
It was after you chilling.
We know this is a bad point because there's no way these can be the same number. The question is this number good?
Yes.
How do you know?
I don't know.
Okay, that's the point. We don't know. So let's take a look at something here, ladies and gentlemen. And this is where you have to look at your numbers and not just go, oh, well, they're good. I'll blindly accept them. Okay? So here's what we're going to take a look at. Now, just in general, ladies and gentlemen, not exactly doing all of the math. These first two, from here to here, went up by about how much? 10. What about here to here? 13. 117 to 130. Okay. How about here to here?
18.
Okay. So what is happening, ladies and gentlemen?
It's increasing.
It's increasing, but is it increasing by the same amount?
No.
No. Is this decreasing by the same amount? Yes. But it's not increasing by the same amount, is it? It's going up each time. So, what I want to look at is this one here. From here to here, how much did it go up by?
Like 25.
Like 25. How much did this one go up by?
35.
So, do we think that's a good point then?
Yeah.
I would say yes. What would make it not a good point?
If it went up by like 10 and 5.
Well, if it went up by like anything
Less than
around
25.
anything less than 25, for sure it wouldn't be good, right? Because it's got to be more than 25, and this is going up to 35. That point may or may not be good. I don't know for sure, but at least I know this. Each time it went up and it went up more. And it's doing that here. Now, if this had come out to be 26, I would have probably been like, no, that's still not a good point. Even though it did go up, 26 or 27, probably not a good point. But, okay, we'll use it. Okay? We'll use it. Now, those who are doing the part with the Vernier software, you're done. You don't need to do anything more with that. Okay? You can bring it back up here, take your stuff apart and bring it back up here. We got everything we need on this spreadsheet, ladies and gentlemen. That's what we're going to take a look at real quick here. Please carefully disconnect the pressure sensor from the syringe. Okay. All right. Hurry. 20. Okay, now, first thing, ladies and gentlemen, this point here, this one that we know is no good, we need to get rid of it. We need to take it out, delete it, okay? Because otherwise it will try to graph it and we know it is no good, okay? Now, down at the bottom here, I have two graphs for you. Let's click on the first one, P versus V. Okay. Now, if you look at this line, ladies and gentlemen, okay, this is a graph of volume versus pressure. Which one did you control in the experiment? We control volume. That is why it is on the x-axis. Okay? Now, if we were doing a lab, which we are not, I would expect you to change the label in the unit down here. I would expect you to change the label to volume, the unit to milliliters. For pressure, I would expect you to change it to the label to pressure and kPa. We're not doing a lab. We're not going to worry about that now. Plus, we lost time because of the delay today. When you look at this line, ladies and gentlemen, okay, when you look at this line, what kind of shape does it have? Is it straight?
No, it's curved.
Okay, so what does that mean?
It's
Thank you. It is a non-constant line.
Yeah.
It is a non-constant line because it is curved in shape. However, it is also what kind of relationship?
It's direct.
This shows a direct. Oh, I never changed it. Sorry.
So this is your fault.
Yes, completely and or totally. That's the one that we should be looking at. Okay.
Can I close this software thing?
Yes, you can. You can close the Vernier software.
Oh, it's for me.
Yes. Yes. Certainly. Okay. Back. Leave Career Center. Okay. So when we're looking at this, ladies and gentlemen, okay, when we're looking at this, we're looking for two things. One, is the line straight? Two, which way is the line going? Okay? Which way is the line going? Here it's going what? Down. Okay, here it's going down. Okay? Line going down indicates what kind of relationship? Inverse relationship. Okay? Meaning, as pressure goes up, volume goes down, or as volume goes down, pressure goes up. That's what we found in the lab.
Is that what Boyle's law is?
That's what Boyle's law is. Boyle's law says these two are in an inverse relationship. Okay? In an inverse relationship. Okay? Now, this last column, ladies and gentlemen, this last column that I have created here, I have taken the inverse of pressure, the inverse of it. What's happening to volume here? What's happening to the numbers here for inverse of pressure? It's also decreasing. What kind of relationship is that?
If they're both decreasing, that's direct.
That is a direct relationship. That is a direct relationship. Okay? That is a direct relationship. So by doing a little bit of math, we have created a direct relationship. Okay? We have created a direct relationship. Okay? Now, here's what Boyle actually found out. Here's what Boyle actually said. Okay? Sorry. All right. So, in a direct relationship, we do what with our variables? Nope. Mathematically, what do we do to them? Well, if you remember when we talked about the relationships at the start, if it is a direct relationship, we divide them. So P divided by V would indicate a direct relationship, correct? Okay. So Boyle's law is an inverse relationship, which means that this is a direct relationship. What would it be in an inverse? It would be multiplication. So P times V. Well, what Boyle found was that P times V equals K.
That was a messy K.
I know. Sorry, that was the ugliest K I've ever made.
What does K stand for?
Okay.
What are you doing?
This is why, ladies and gentlemen, I do not
You make a straight
use
line,
cursive.
and then you make
Don't
one
do it
line up,
cursive,
and
just
then
put normal.
there you go.
Okay. So what does K stand for?
Constant. Kelvin.
K stands for constant. K stands for constant. Now, it is a constant for this gas, assuming that we do not change what two things? Nope, we can change them all we want.
Temperature and amount.
Temperature and amount of gas.
So those
We
have
can
to
only
stay
work with two variables if we want to see how one variable affects the other. So the temperature and the amount of gas need to stay constant. They cannot change. We didn't change the temperature of the gas inside the tube. Now, how do we represent amount of gas? What letter? N. V. V. V is what? Volume. So these two things here are variables. They are changing. For Boyle's law, these two things are constants. They are constants. Okay? They are constants. And P times V equals a constant, a number that does not change. What that means is if I know a pressure and a volume, it is equal to a constant. But a different pressure would give us a different volume, and they should still be equal to the same constant, which means P1 times V1 equals P2 times V2. In other words, we could predict any new pressure if we figured out a new volume. That's what Boyle's did. That's what his law allows us to do. It allows us to find the new... Yes. You keep saying that. Okay. Well, I'm just doing this one thing called teaching.
Are you?
Okay, I'll send her. Bye. Rose! Down to Career Center. So, what Boyle's Law is going to allow us to do is Boyle's Law is going to allow us to find a new pressure given a new volume. Or a new volume given a different pressure. As long as we don't change what? The temperature and the amount of gas. So if we unhook our syringe in the middle of the experiment and move it around, now you're changing those conditions. You're changing the amount of gas that would be inside there. Now that constant doesn't hold. This is not what we would call a true constant. It is not the same number every single time. It is a constant for this pressure and volume under this temperature and amount of gas. And if we change these, we would get a new constant and still be able to do this, but it's not going to be the same number every single time.
Wait, what if we change the pressure or the volume? Would that change?
If we change one of these, either one, pressure or volume, the other will adjust. And if our pressure goes, well, let's say our volume, which we were controlling, if instead of going down with the volume, if we had gone up, we had started at 30 and gone up to 40 and then 50, what would have happened to our pressure as the volume increased? It would go down, but we could find it. We didn't do 90 for a volume. We could find what it would be, though, for the pressure, given these conditions, yes.
Is this going to be on our quiz on Friday?
No, this is not going to be on your quiz on Friday. The last thing on your quiz on Friday was those conversions that we did.
Do those worksheets that you gave us have any of those conversions?
No, they do not. They do not. The ones that I gave you, the ones that we just did in the lab, that's the only ones that I gave you for that.
Isaiah's so cooked.
Huh?
Why is he not in class? He's so cooked.
Mr.
Wait,
Grant does
wait,
not
wait.
speak that language.
He's so cooked.
Hold on.
Oh, are you gonna Google it?
Hold on. No, it's Yuritzi's week to watch him.
Oh,
Ask her. It's not mine.
Where'd you put Isaiah?
She lost him.
It's your week to watch him and you lost him?
I didn't know it was my week to watch them.
Didn't you get the schedule? Austin sent it out a month ago. Who was in charge of Isaiah every day? How the heck would I know?
Because
You go to
you're
his
his
house,
favorite
Austin.
teacher.
I'm his favorite teacher. You guys need to look up the definition of favorite in the dictionary and find out what it really means.
If he's Isaiah's favorite teacher, I'm his favorite teacher.
Right. Exactly. Stand right there.
No.
Stand right there.
He's putting you in the corner.
Stand-
brother.
No, he's gonna
Stand
go
right
like,
there.
okay, now run. I
No.
already know.
Bro, he's so
Run
cooked.
real fast
See,
at
soccer
me.
is a sport.
I'm about to get
Look at
a
this.
0 on this quiz.
Yeah, look at this.
Look at that.
Look.
Why?
Suck it.
Because they make a duffel bag for it?
Yes.
Yep.
Then why aren't you playing soccer? Go away, go away, go away. Get out. Adios, arrivederci. You gotta go now. Bye-bye. See ya. Arrivederci. Goodbye. Adios, adios, adios. Goodbye. Goodbye. What the fuck is up with my goddamn...